Awesome. Thanks so much. All right, as mentioned, Spencer and I I'm a product manager, engineer at Google on GKE. Spencer actually leads some of the engineering for what we're doing with Ray on top of GKE as well. Pretty excited to talk to you guys a little bit about right-sizing Ray and scaling Kubernetes. I think the hardest thing about putting this presentation together was trying to find a way to fit platform building into 30 minutes, and I'm probably going to miss a bunch of stuff, so don't hold it against me. Happy to answer any of those other extra questions in the Q&A or whatever I missed or outside in the hall after. All right, let's get into this a little bit. So look, building a platform for serving AI/ML workloads is hard. There's so many things that you have to enable, especially as you're working across multiple teams, the different frameworks that might be out there, the tools necessary for serving, training, post-training, data processing, et cetera, the infrastructure underneath it, handling obtainability and scaling as well. Now, Ray does make that a lot easier in terms of enabling those AI/ML engineers and empowering them to do what they have to do. It unifies that development lifecycle a little bit too and starts to streamline things. And there's a lot of work that we've been doing together with Anyscale on top of Kubernetes to make that work really, really well. And a lot that we're advancing there. But when you start going from that initial phase of having that happy developer team, discovered Ray, starting to work with it, and then more hear about it, and you start getting a lot more out there. Eventually, someone up top is going to say, we need to standardize this platform, make sure the right governance controls is around it, and ensure a better experience for those folks. Also get them to go from like a mosh pit down to like line dancing. The way that we've been seeing this happening a lot, and you heard some of this during the keynote, is on Kubernetes. And part of the way that we came together with Anyscale and decided to partner with them this past year in the beginning was to see how we can kind of like shape that vision of the distributed OS for AI/ML with Ray and Kubernetes together. And there's a lot of things that we're doing there through KubeRay and Anyscale and the Ray core itself to actually get there. And there's a lot of reasons why we're seeing this movement onto Kubernetes. It's a standard, a lot of customers are using it, but also allows customers to do a number of different things around how they declare their infrastructure to get them deployed out there, optimize some of the resource orchestration as well. And then on GKE, what we're seeing is that they end up doing that as well and mixing some of those workloads, mixing GPUs and TPUs, thinking about training and inference together. Now, when you start getting all of that bundled together, it gets kind of hard to figure out how to best set up those platforms and enable them. So let's talk a little bit more about that. When we start talking to customers about it, I think we think about this in 3 different phases of the cluster lifecycle. One of them is like, how do you enable and provision out that seamless developer experience? Then how do you get them through that sequence of where performance and scale starts to matter as they scale up and start to enable those workloads? And then, of course, troubleshooting and observability. Lifecycle is part of that too during day 2. And when we start thinking down each of those different areas, part of this comes down to having a platform that is performant and scalable, that supports some of the advanced scheduling things. DRA came out, and how that enables you to take advantage of GPUs and be able to declare those and pass that down becomes important. RDMA and some of the other technologies that are out there and folding that all together. KubeRay really starts to matter, especially on top of Kubernetes, because that's that harness that kind of brings all of it together, allows some of that seamless scaling to take place, take advantage of some of the components that are there, some of the scheduling that has to happen as well. And then we've seen that there's a desire for more and more accelerator types, and both Ray as well as Kubernetes coming together to enable that, especially for those different workloads. As we start looking at moving into day 1, being able to actually start saving cost and optimize matters, minimizing disruptions as you scale, resizing as you need to as the workload shape changes, being able to get the startup so you're not getting any of that lag in the beginning. And when you start getting to larger scales, even like the extra 3 minutes possibly that you could shave off starts to add up pretty significantly, especially when you start looking at serving and long-running workloads, as well as helps with training too. Performance, storage, and networking. I mean, when you start thinking about your weights and biases, as well as like the model loading and all those other things, having really fast storage starts to really matter. And whatever platform where you lay it out needs to actually be thoughtful of that. We've also seen a lot of cases where like Anyscale platform and what they're doing to optimize the libraries and the performance and what they can layer in there to handle larger scale types of use cases really helps minimizing out-of-memory conditions that might take place, as well as having things complete in a reasonable time frame. And then when we get to observability, just correlating the Kubernetes and the Ray side so you can understand what's causing the problems. I don't have that many of these marketing slides, so I'll get through this quick. We do have a perspective on that on Google in terms of how we layer that all together. And really what we've been kind of optimizing for is really improving that performance angle, the latency that takes place, having some of the optionality for when you think about obtainability to be able to get it when you need to. It starts to get really interesting when you start looking at like gang scheduling and being able to have fallback options and be able to do as much of that out of the box as possible. And I think just the main thing is that we're kind of trying to think of that cohesively, so it's not in the silo of just GKE, but across the entire stack and across all the services and how they come together. Ray's been pretty interesting in the conversations, especially as customers continue to adopt more and more TPUs and it gets more and more popular. As they think about that shift from training to inference or GPUs to TPUs, helping make that shift along the way starts to matter. We've also seen where different generations, customers are leveraging for different use cases as well. And being able to optimize against those as well as then optimize cost starts to get really, really helpful. Let's go a little bit deeper down and talk about some of the patterns in the platforms themselves. And so I think when you start from the RayCluster level at least, the idea behind ephemeral clusters and persistent clusters, there's different scenarios and use cases for that. There's some inherent benefits on the ephemeral side of things, and a lot of where things started off, much like with Kubernetes, as with Ray. Ephemeral clusters is the idea, deploy the job, it kills and dies at the end of it. All those nasty problems with upgrades go away. But it's also a good approach even for the condition around, like, in some cases, like batch training where you can get away with that, data processing, and so even for like CI/CD where you can be able to just test suite and then just make the pull request and execute all of those things. There's also some validation value around that because you don't need to worry as much about the resource distribution underneath it. It's not going to be long-lived. And while you have to think a little bit about quotas at the inception of that, you don't need to think about that long-term. Persistent clusters, especially you start layering and thinking about a Kubernetes cluster with having multiple Ray clusters on top of it, have some challenges, but also some obvious benefits when you start thinking about model serving, as well as some of the experimentation scenarios that might take place, carving out resources for developers and making sure the right security parameters and mitigating noisy neighbors and ensuring that intercommunication where it shouldn't happen doesn't occur. You establish it, leave it in place. Debugging gets a bit easier as well because you're not losing those clusters in the logs from the Ray side when it goes away. But there's things to be thoughtful of there. Now, when you start putting that on top of Kubernetes, to start thinking about that correlation between the Ray cluster and its perimeter relative to Kubernetes and the constructs it has available. A lot of customers are thinking about this as they start to standardize and getting to more teams coming in and scaling that up. How do they layer this on top of there, and how do they set this up in the right fashion? So we often see them doing this, usually they wrap a namespace around the Ray cluster itself. We've also seen some scenarios where they start to think about like C-group isolation and leveraging that along the way. From an authentication perspective, there's areas that we're actually proposing some things up in for Kubernetes native Ray authentication as well. We'll see where that goes as well along the way. But we start thinking about it in those lines. And as you think about those namespaces and trickling that down, all the properties of our own permissions and security, et cetera, from a Kubernetes perspective, we kind of want to lay those in at that point. And then from there, we start thinking about where does that fit on top of Kubernetes itself. We've seen a number of interesting patterns. The most common one is where Ray cluster one or many inside of a single Kubernetes cluster. We have seen some where they might do a Ray cluster across multiple Kubernetes clusters, largely because of different machine distributions and machine types as well. But even there, as you think about the cluster itself, the Kubernetes cluster, you can kind of think about this from like an isolation perspective or distributed across. In the perspective of a node pool being a specific machine type and all of the same type within that, you can have different, if you're using different accelerator types, if you're having CPU-centric ones, different machine shapes, you can separate those across the node pools and then layer the Ray clusters across them. There is some scenarios where you may want to be able to actually isolate a Ray cluster per node pool as you think about the life cycle and how that grows up. Maybe you have some long-lived Ray clusters, some short-lived ones. There might be some benefits as you think about life cycling that along the way. But there's some secondary things to be thoughtful of too. Inherently, when you start deploying the clusters across node pools, you get the ability to think about taking the head nodes and using the taints and tolerations and distributing them across as well for better high availability. So you think about fault toleration for the nodes and being able to leverage what's best with Kubernetes, tied in with Ray now, to be able to restart those nodes or re-provision them, becomes a little bit more flexible to handling that capacity along the way too. So those are things to think about as you're starting to layer them on. we've seen those couple different patterns along the way. As you start thinking about those namespaces and that multi-cluster management, there's a couple thoughts there. Just as you think about those different clusters, Kubernetes provides them the tooling to be able to facilitate that layering that in and thinking about that the permissions. As you start putting in front of that, like the load balancers and thinking about port forwarding to the RAID clusters for giving access, what they have access to then stays within those namespaces. Small plug, GKE does have some patterns we've seen where the same team or sets of individuals that might need permissions across clusters, being able to sync permissions across them in the different namespaces. So if they're submitting jobs and working across RAID clusters on different Kubernetes clusters, we do have a way that we kind of sync that across and maintain those permissions and keep that synchronized. And also then slicing out the resources along the way too. One of the last pieces I'll just bring up before we kind of dive deeper into these areas a bit more with Spencer is KubeRay itself. We're obviously big advocates of KubeRay being GKE and Kubernetes, but it's actually super important. It's what allows us and Kubernetes to be able to more effectively perform the operations. It maps all those Ray objects down to like the Ray cluster, the Ray job, and the Ray service, so we can do things with that. Label-based scheduling takes advantage of that. Autoscaling becomes a lot more dynamic and seamless and reduces some of the time gaps along the way. The cleanup processes and workflows get a lot better. The detection around node handling and being able to return that back in becomes imperative, and that KubeRay enables all of that. But even more important than that, I think one of the most common challenges that we've heard from customers and where they continuously looking for better options is when it comes to actually observability and troubleshooting. And there's optionality there for obviously passing those messages through. But on GKE, we have a managed add-on, and out of the box, we'll do the correlation for those Kubernetes events with the Ray job events so that you can understand where the failure is coming from. And was it a node-level thing? Was it a Ray thing? So bringing that together gets super important. But optimizing these clusters and ultimately getting to better price performance, so we're going to hand it off to Spencer here to keep going.
Thank you, Raja. So I'm Spencer. I'm a software engineer at Google. So I am going to talk a little bit about optimizing your Ray and Kubernetes stack. So optimizing performance to maximize your spend becomes incredibly important as you scale. And I'm going to try to go over 4 areas where you and Kubernetes can better allocate your Ray resources relative to your Ray workloads that need them while reducing idle resources and disruption. So we're going to try to go over dynamic resource allocation, or DRA, to improve GPU efficiency, autoscaling for just-in-time capacity and right-sizing resources, tools for faster node startup times, and job scheduling and Kueue with a K to manage quotas and resource allocation. So before DRA, accelerator sharing on Kubernetes was pretty inefficient. You had to have homogeneous nodes only, a fixed instance group size, partition size, fixed time sharing settings, and it was difficult to align GPU and NICs for best cross-host performance on PCI Express hosts. But with DRA on 1.34 is now GA, platform admins, for example, can deliver a higher throughput via topology-aware scheduling when your workload team is trying to develop an app. You could give your engineers the ability to co-locate pods with an accelerator that's on the same PCIe route, which can prevent fragmentation and ensure that all of your users are getting the best throughput they can. And then also, as a developer and a researcher, you have the ability to leverage fine-grained resource sharing to improve resource consumption efficiency. You can configure whether you need sort of multiple containers in one pod bound to one accelerator, or one-to-one in this example, or in node 4, sort of one container to many accelerators. So you have that flexibility of topology. Moving on to autoscaling. Ray Autoscaler v2 brings improved interoperability between KubeRay and dynamic scheduling with in-place pod resizing, IPPR, and vertical pod autoscaling, or VPA. With these capabilities, it can be really valuable to leverage label-based scheduling as well. So node startup time here, you can see, is kind of a key area. Your job is going to be pending while the autoscaler is considering your requests, provisioning new pods, and Kubernetes autoscaler is spinning up new nodes. We really want this area to be quick. So we want to allow pods the resources they need to initialize quickly before any potential downscaling after the initialization has been complete. And I'll talk a little bit about some of the optimizations GKE has for startup in a few slides. Label-based scheduling is, label selectors are really important to add on to this because the autoscaler will leverage those labels and those groups to consider your scaling up. So we find that pod resizing is really best for sort of long-running use cases. If you have a long-running RayCluster or Ray job and ephemeral clusters, short-term jobs might not benefit as much. And of course, RayServe is a fantastic use case for this, so you can scale up as your sort of inference demands grow. So in-place vertical pod autoscaling enables scaling optimizations that sort of minimize your disruptions and mitigate any restart time or lost cost from like idle resources or restarted resources. If you just think about your workers nearing its resource limits and there's underlying space on that machine, you can take advantage of that space and resize that pod like in place without, throttling, ooming, or deleting the pod. On the node startup time we find can take as much as 3 to 4 minutes or longer, depending on the model sizes or the image sizes that you're pulling down, maybe even up to 20 minutes in the worst case. Optimizing image and model pulls then is sort of the first step to bringing down that startup cost. And then leveraging image caching and streaming can help you reduce times even further. So for example, on GKE, we find that using image streaming and attaching sort of preloaded secondary boot disks with your models already on them can improve. You can get up to 80% lower startup times. You can get up to twice as fast node readiness and up to 20% less unused idle capacity. All right, so on resource sharing, let's say that you're a platform admin and you're running a cluster where a whole bunch of different teams and a whole bunch of different workloads are running concurrently on shared hardware on a shared cluster. Your resources aren't unlimited, so you'll soon find that your cluster becomes constrained and oversubscribed. Your teams are struggling to complete their training runs on time. Maybe they're even like deadlocked against each other. How can we address this? We have Kueue with a K, not a typo. Kueue is a batch job scheduler for your teams, which allows you as a platform admin to set policies for your jobs, your teams, and your users. So you can sort of specify which teams can use which resources and which provisioning methods, which teams can borrow resources from one another, which jobs have priority and can preempt other jobs. And Kueue is Kubernetes native, so if you're trying to build something like this to manage your own Kubernetes clusters, you don't need to. It's already there, well supported, part of CNCF and everything. And so Kueue will help you squeeze the most out of the infrastructure you have, in a configurable way that you define the policy for. So we can walk through a quick example of how you might use Kueue. Here we have sort of 4 teams that are going to be submitting jobs through Kueue, and then we have a couple different machine classes in different regions or zones. So first, we have this low priority workload that is submitted, and it gets to run on a nice reserved instance because there's nothing else running, so it can go ahead and move through the queue. And then as we add more requests, more requested pods and containers, they can go ahead and file in on the available spot machines that we have, because now we're out of reserved instances. So then, let's say another team comes in with their high priority workload that needs to run right now. It has priority over the green one that we've already submitted. That can go ahead and preempt the reserved machine that we have, move the sort of green job back into the queue, and then now we have the red job is running on reserved instances, and then its remaining requests can go ahead and run on those on-demand instances, and we see they are not preempting the spot because there was available capacity that was preferential. All right, and then finally, you read more about this. It's just a quick touch. This blue job can be placed sort of in available headspace for compact placement. All right, so I'll end with talking a little bit about developer experience before handing back to Raja. So after you've provisioned, you're their platform administrator and you've set up your Ray cluster, you want to hand it off to some of your Ray users. So you have some flexibility in exposing that Ray cluster endpoint to your users. The quick and easy way is on the left is for your Kubernetes users to use kubectl, use port forwarding, and this is a little bit of a raw, quick and dirty way to do it. And if you want to use the Kubernetes, the kubectl Ray plugin as well, that's a way to help make it easier. Alternatively, if you wanted to provide a very managed solution as an admin, you could try to set up a load balancer and expose an address, maybe set up some sort of gateway, and that's gonna put a lot more choices on you as an admin to choose whether you were having some private address space that you want to give your users access to, or a dedicated URL or some auth solution in front of it. But if you're trying to just make something available to users that just need to set their Ray address, like environment variable, like maybe that's the best solution for them. Another developer experience improvement that's now available is the work that we've been doing on label-based scheduling, which allows for selecting a class of resource to run on, a class of resource instead of a quantity of resource. And so that brings a Kubernetes native concept, label selectors, to Ray as a first-class citizen. Google and Anyscale have collaboratively defined this type of scheduling to be even more complementary with Kubernetes. So this label-based scheduling API in Ray works great with custom compute classes on Kubernetes. Your Ray users can select their compute type and fallback strategy when compute is unavailable directly from their own Ray code, and then Kubernetes will go ahead and use that information when it's scheduling on nodes. And then likewise, on Kubernetes, your platform admin can pair the Ray label selector with custom compute classes, node selectors, and node affinity rules, so you can have the same rules being applied for scaling up your nodes as are being used for scheduling your Ray workers. So here's a quick example of like maybe you're running a sort of a batch inference pipeline where you want to use these label selectors. A common pattern, of course, is to sort of mix CPUs and GPUs in your inference pipeline. You're going to do your pre-processing on some CPUs and then hand it off to some GPUs. So in this example, you've got the first two steps where you're doing CPU pre-processing. We haven't included the label selectors for those. And then inference is scheduled on accelerators, passing the pre-processed data set into this time series generative model. And so as you see in the Ray label selector API, we can specify a preferred list of accelerators for the inference step, preferring these H200s on Spot, then H100s on Spot if those aren't available, and finally plain old H100s. All right, finally, so let's say we've gone and we've run that pipeline. How can we get some observability into its performance? Our developer might be using the sort of Ray dashboard directly against that endpoint to look for application level issues, failed tasks, actor crashes. And the developer can view any logs like that way, but they can also view any lost logs that might have been, the Ray had crashed or moved or something, and they can find those collected by the Kubernetes platform, thanks to our platform admin. And our platform admin may be using kubectl to administer Kubernetes pods, logs, events, node pools, and everything, as well as any metrics scraped from Prometheus available through Grafana that they've configured. And on GKE, we make that easy. We enable a lot of logging and metrics collection services out of the box. And as Raja mentioned, do some correlation for those events as well. So I'll hand it back to him with that.
Cool. Yeah, and just one thing just to add in there, actually, in that last one, especially start thinking the whole thing coming together. We talked a little bit about Kueue for being able to do some of the job scheduling. We mentioned all the ways that it works, and then the label-based scheduling that thereafter, and then that use case as well with combining CPU and GPUs. That actually comes together in the sense that when you start thinking about gang scheduling, Kueue helps there with as you have the multiple Ray clusters behind there, the multiple jobs getting deployed out, to actually sequencing those right in where they need to go to. Being as you think about a lot of these Kubernetes clusters are supporting multiple workloads to take advantage of and optimize the capacity that's on there. Kueue kind of sits at that very front end of that to kind of figure out where it should go to, maintain those quotas along the way, and then as you scale up, it'll dynamically understand that and understand where there's available headroom and where those placements can actually go towards. So as you're thinking about all this stuff, as you're bringing that together, it all folds together. Kueue kind of helps there along the way, which is kind of supporting that entire experience. And so when you start doing some of that work with correlating the observability and understanding what's happening out there, I think the most common thing that we've heard is that you never have an understanding, a job failed, you don't see the reason why in the Ray console, it's not in the Ray events. Oftentimes there's a Kubernetes or node level issue that's taking place. We've actually done some of that work, as you can stream back through all the logs and the metrics, everything else into Prometheus Grafana stack. But actually doing that correlation and mapping them together gets a little bit hard to do. And we've done some of that work out of the box. KubeRay is critical to kind of facilitating that. even the previous part, but also actually automatically when you go and deploy this stuff on GKE, use the managed KubeRay add-on, it'll populate these views, unified views, it'll do the correlation at the logging level to understand that type of problem, to trace back where the issue came from as well. One of the things that we're thinking about, and this is just a small brief plug, there's another session that's going to think about it more, is that for those ephemeral clusters, there's a challenge that of course takes place. As soon as the job's done, it terminates. What happened? What was the root cause? Where was the issue? So the idea behind that, and more importantly, you might have the logs going externally, but the correlation back to the job that was executed and mapping that through gets difficult. Ray History Server is something that we're thinking about. That's our branding naming, but something that conceptually is something we're working closely with Anyscale on to see how do they think about that correlation of those events for past events, tracking that through, mapping it, and how that actually gets tied together. Make it a little bit easier for you to go do that troubleshooting later down the road too, and understand what's happening over time. So this all gets funneled through KubeRay, funneled through Kubernetes, and making sure that we understand all those relationships. If you want to learn more about this, we're in the Ray grounds. Come visit us at our booth. We're at P2, so just inside and off to the right. If you want to learn more about this, there's a lot of content around like deploying Ray on top of Kubernetes, on the GKE content itself as well, and of course on GKE, and some of those links that are up there to tell you a little bit more about that. We have about like 3.5 minutes left. I don't know how many questions we'll be able to get through, but we'll take as many as we can, and we'll try to meet as many of you afterwards and get more outside. So, any questions? All right, I saw your hand go up first.
Yeah. So the question is both on the infrastructure side. Is the KubeRay operator still good for the existing Kubernetes clusters? Because I saw the lifecycle management for all the create cluster and send it to that.
Yeah.
But what about the existing clusters where we have everything else on it, but we just want to try out the other cluster?
You can deploy the operator on an existing Kubernetes cluster for sure. I think one thing just to be thoughtful of is some of these advancements came in different versions. Like IPPR came in 134, 131? Can't remember now. Making sure that like the Kubernetes version of that existing cluster is there to take advantage of certain features. You can still deploy it out there, but there's certain features on the Kubernetes side, for example, that will only become available in the newer versions. So as long as that's there, but you can deploy it on your existing cluster for sure. Yep.
One thing that I found that you mentioned is latency, particularly if you're trying to switch between images that aren't cached on different machines. I deal with some of my clusters are geographically disparate, the nodes.
Yeah.
So the time to actually get the image cached on those machines can be a blocker. So I was curious if you've seen any solutions for like machine-to-machine sharing.
Oh yeah.
For like ones that are nearby to facilitate a faster connection, or if you have other.
Yeah, so I probably should have, I don't know if you heard the previous question, but I'll recap this one. The question was really about, is there methodologies to get better machine-to-machine communication, get past some of the challenges that are there in a geologically distributed deployment? One, I think when it comes to the inherently from like an ephemeral cluster perspective, I think, there's aspects of that, I think, but ultimately what we've seen patterns that why they choose one or the other is really more to the use case as opposed to performance. But relative to performance, in terms of getting that better communication across, there's a couple of ways of approaching it. One of them is with DRA, it actually enables that topology-aware scheduling. So I know you said geographically distributed, but where you're just trying to get machine-to-machine, node-to-node communication optimized, that topology-aware scheduling will allow, like there's certain things that we'll do out of the box on GCP where we'll make sure that they're rail-aligned in the closest rack, if not the same rack itself. So the super low latency of placement inherently out of the box. That becomes super important for facilitating that experience and getting that really fast. Some of that also comes down to underlying storage. So we leverage like hyperdisk ML for getting really fast storage. We have a managed cluster option as well. So some of those underlying bits become important in the newer chips and the newer types of architectures, RDMA for that networking. We also have some networking fabric layer things that we do to optimize to get really high speed throughput. That starts to be important when we start thinking about like cross-region. And then the super low latency, when you're talking about like geographically dispersed, I think there's probably another layer between when you're operating between, the same cloud versus like on-prem versus cloud or like multiple clouds. And some of that comes down to the placement in which regions that you're deployed into and their connectivity to those other regions and those other clouds. And that's something where you're going to want to talk a little bit with some of the folks that are there just to get an idea of where is ideal given your landing places to get better throughput, because not all of them are always created equally. And so it really kind of depends a little bit on some of those conditions. OK, I am running out of time, but if you want to grab a question and meet outside, they're going to kick us off the stage here in a moment. But we'll hang around and answer more. Thanks so much, folks.